The research program of my work consists of several steps. At first, it is a study of the terminal instabilities and spatial localization due to the Lucas behavior, the Motivation effect, and the necking effect during uniaxial tension tests. The second step is about study of the influence of the loading system stiffness on the effects of spatial time inhomogeneity. Also, it is interesting to assess the influence of the stress concentrators and the additional cycle loading on the serrated flow and the yield delay effect. There is some example of our results to show the main effects about I will talk. So the test program includes the uniaxial tension of the flat dot bone spacements of carbon steel and aluminum magnesium alloy, the uniaxial tension of the flat spacements with 1 and 2 holes, also the spacements with additional deformable parts and with complicated geometry. So this is a special spaceman with 2 L-shaped holes. And here there is a table. This is chemical compositions of 2 materials which are under study. Test procedure in my work includes the analysis of the strain fields by the digital image correlation measurement system. So in our laboratory we have several sets with different configurations, as you can see, with different cameras resolution and with frame rate up to 100 frames per second. Also, we analyzed the temperature fields by using the infrared camera lead SC series. The loading of the spacements were performed by use of the electromechanical testing system in Stern and by the semi-hydraulic reaxial testing system. So, at first step of my work, we studied the materials behavior patterns during uniaxial tension tests. So we make a set of different tests to analyze the process of initiation and propagation of the Lucas bands during the uniaxial tension. As you can see, there is an evolution of the longitudinal strain fields along at the stage of yield plateau forming. Here it is an illustration. It is a set of profiles which are calculated along the gauge length of the spaceman at equal time steps. As a result of this test series, we have several results, such as we calculated the velocity of the propagation of the single strain bands, and it is interesting that the ratio of this velocity to the loading rate is practically equal, and it's about 100. If we look at the distribution of the longitudinal strain field, we can see the configuration of this strain band, and another parameter we analyzed, it is average value. This is average value of the strain on the front of the band. And I can say that increase of the loading rate causes the proportional increase of the velocity of the strain band's propagation. During further loading, we can observe the Motivation effect, as you know. So we performed a big number of tests to analyze the different types of the bands initiation and propagation. There is two examples of the continuous propagation of a single POC band and the stochastic nucleation of bands. And about this I want to talk more. So if we calculate the profile along the gauge length of the spaceman, we can see the propagation of the single strain bands along the spaceman. This is profiles for one single band. If we draw a set of these profiles during the all loading from the start to the post-critical deformation stage, we can see that sometimes we have a leveling of the strain field. So these arrows correspond to the propagation of the single band. When the one band reached the opposite part of the spaceman, the level becomes practically equal on the surface of the spaceman. So we can see quasi-periodic effect on during the uniaxial tension of this on this type of material. So to illustrate this effect, we calculate the time dependence for the moments of periodic leveling off. So we can see, and if we can see at this diagram, it is a time dependence of the this coefficient. It is a ratio of maximum level of strain to the mean value. So we can see the increase of the serrations with the increase of the macro strain level during tension. So the next part of work was about the study the influence of the loading system stiffness on the effects we are studying. We have two groups of spacemans. First, it is a flat spaceman with two L-shaped holes. So we have a gauge length of spaceman, the control part, and two additional parts. By use of them, we can manage the stiffness of the loading system. So in our test, we have this range of stiffness of the loading system, and we have several results. So the loading stiffness is influence on the serrations on the deformation diagrams, and on the surface we can observe complicated system of POC bands during the tension. And it is interesting that the quasi-periodic character of the development of plastic flow is observed as well as on the standard flat samples. Another type of specimen is a flat specimen with additional deformable part. By use this geometry, we have this range of the stiffness of the loading system, and there are some deformation diagrams and the zoomed parts of it. And we also analyzed the profiles of strain along the spaceman, and they're based on the analysis of the strain fields and based on temperature fields. So we also can observe the quasi-periodic character. Okay, and another part of my work is about the study the influence of the stress concentrators on the religious behavior. First of all, we test the standard flat samples to have the main parameters of the effect. And after that, we test the specimens with one hole and with a set of two holes. And we analyzed the evolution of the inhomogeneous strain rate and temperature fields on the surface of such geometry specimens, and we interrelate the strain and temperature fields as well. As a conclusion, I want to say that we provided the complex test on the study of the spatial time homogeneity on the plastic flow due to the Lewis behavior, the multidimensionality effect. So we analyzed the strain and temperature fields. We have the set of data to characterize the homogeneity of plastic flow. We assessed the influence of the several mechanical parameters on the behavior patterns of the plastic flow, and now my group is working on the study the influence of the additional cycle loading on the patterns of the serrated flow. The research program includes 3 steps. The torsion test, the uniaxial tension test with additional torsion cycle loading, and with additional tension cycle loading. This is our center, the Center of Experimental Mechanics. We are from Perm, from Russia. So, thank you for your attention.